Welcome back, everyone. Today we're going to be jumping back into the C programming language and getting into sections 2.1 and 2.2. We're going to talk a little bit more about variables, in particular variable naming principles, dive into data types and sizes, and lastly get into a little nitty-gritty with qualifiers and headers. As always, I'm learning this stuff along with you, so feel free to leave any critiques in the comment section.
So in chapter 1 we talked about variables, but we didn't necessarily lay out the foundations of naming principles. In chapter 2 they cover this, talking about what you can and cannot do when naming variables. So let's start out by doing what we always do, importing our library and creating our main function. And then we're going to create an integer, and to demonstrate something that's valid, we'll say total score equals 10. And then we will print this out. Let's compile this and run it. And of course this works. So as you can see, having this case is totally fine. What happens if we move it to the front? Once again, this works too. So you can start with capital letters. What you cannot do is start a variable with a number. Observe what happens when we say second value. As you can see, it's already sensing an error, making it red. But to demonstrate this, we'll go in and try to compile it, but of course it won't work. It says invalid suffix, nd value on integer constant. So it's specifically referencing this 2, which is invalid. Now what about underscores? We can say total value and compile this, and this will work. But what happens if we move the underscore to the front? Do you think this will work? It turns out it does. In fact, you can name variables anything in C as long as it starts with either a letter or an underscore. Any other symbol will be denied. Additionally, C is case sensitive, meaning if we define a variable int num equals 5 and int num equals 10 with a capital N, and then we say we'll print the lowercase num and then print the uppercase num, what we should see is that it differentiates between the two values. And as you can see, that is true. Now let's talk about types in C. There are 4 of them. First, we have char. This stores a single character. For example, A or B or any other character you can think of. It takes 1 byte of storage, or 4 bits. Next we have int. This stands for integer and simply stores a number. An example is 1, 2, etc. Integers are generally 4 bytes. Next we have float, used for single precision floating point numbers. In other words, numbers with decimals. An example might be 5.4. These are generally 4 bytes as well. And lastly, we have double for double precision floating point numbers. This could also be 5.4, just like a float. The difference is doubles are generally 8 bytes. I'd like to demonstrate these types and their respective sizes by doing a quick exercise in VS Code. Through some research, I found there's a function in C called sizeOf, which takes a variable as its parameter. it returns a type of unsigned long, and it is the size in bytes of this variable. So let's create some variables in main. Char letter equals a, int count equals 123, float temperature equals 36.6, and double precise value equals 3.14159265359 pi. Now I'll write print statements for all of these variables below. To clarify, I'm using %zu as a symbolizer for unsigned long in order to print out these size of variables. Now we'll write return 0 and then get into the compiler to make this work. As you can see, the char is 1 byte, the integer is 4 bytes, the float is 4 bytes, and the double is 8 bytes, demonstrating everything we just learned. Another concept Chapter 2 teaches us about is qualifiers. Qualifiers are keywords which modify the properties of variables. One example is with short and long, two qualifiers which can be applied to integers. The intent is to provide different lengths of integers where practical. Short is often 16 bits long, or 4 bytes, whereas long is typically at least 32 bits long, or 8 bytes. However, these values are variable to change depending on the machine. Another example of qualifiers are signed and unsigned, again applied to integers. Signed numbers can be either positive or negative, whereas unsigned is always positive or 0. The last part of section 2.2 discusses standard headers in C which contain symbolic constants for all these sizes that we can use. For one last exercise, let's use the two headers defined in the text to see what they have to offer. We'll include float.h and limits.h. Let's start simple with integers. We'll obtain the min value and the max value using the symbolic constants int min and int max. When we run this, we can see these two values displayed in the terminal. Let's take a look at characters, specifically signed characters. We can once again say minimum and maximum. And this time, our symbolic constants are schar min for signed character and schar max. Once again, compiling these gives us our limits. At first, I was confused as to why unsigned characters only had a max symbolic constant, uchar max. However, what I realized is that the range of an unsigned character is from 0 to 255, as you can see in this terminal, and therefore there's no real reason to have a symbolic constant for 0. We just discussed the difference between short and long qualifiers, so let's take a look at it using their unsigned symbolic constants. We'll say unsigned short max equals u for unsigned, and unsigned long max equals lu for long unsigned. And the symbolic constants are u short max and u long max. Compiling this shows us that there is a massive difference between a short and a long integer. Finally, let's use the symbolic constants defined in float.h to take a look at the difference between float and double. First, we'll say min equals %e. Originally, I had tried to do %f. However, this yields 0 because of how small the minimum value for a float is. Therefore, we have to use %e to get a valid result, as %e is for scientific notation. Likewise, we will do max %e, and our symbolic constants are FLT min and float max. And then we will do print double min, also using scientific notation, and dBl min, dBl max for our symbolic constants. Let's compile this and take a look at the difference between float and double. Much like short and long, you can see that the difference in memory and space for float and double is extremely different. This is to the -38th power, while this is to the -308th power, a massive difference in values.
If you learned anything today, please consider liking and subscribing and sticking around the channel for more videos like this. Let me know in the comments if there's anything in particular you'd like to learn about going forward.